In this question, we have to determine the Thevenin's voltage and resistance. Okay. Now, V0 is equal to minus 75 I into 30K. And how do we get this? Because this current 75I will be confined to this loop. As a result of which V0 will be this resistance multiplied by the current that passes through it. Since the polarity is taken as this is positive and this is negative, as a result we get negative sign because the current is flowing in this direction. So we will have positive and negative. So V0 will be minus 75 I into 30K. Okay. Now I will be determined from this particular loop. Okay, so this current is what I is. So for I, the equation will be V in minus this divided by this. So it is V in minus V0 divided by 10 power 4 divided by the resistance, which is 1 kilo ohm. Okay, now simplifying this, we are substituting this particular value of I into this equation. Okay, so V0 is equal to minus 75 V in minus V0 by 10 power 4 divided by 1 kilo into 30. So this will go off. We have just 30 here. So V0 minus 75 V0 by 10 power 4 into 30. This is the second term. Okay, first we are bringing this second term to the left. Be equal to minus 75 into 30 V. Now V0 minus 0.225 V0 is equal to minus 75 into 30 V. Now we will get V0 is equal to minus 2903 V. See, this problem is very simple. We have to just manipulate the values that we get from either loops, and then from that we can deduce a relationship between V0 and V. Okay, now we have to determine the Thevenin's resistance. Now that we have determined the Thevenin's voltage. Okay, for determining Thevenin's resistance, we will first find the short circuit current. For that, we will short this, and once we short this, this current will pass like this. There won't be any current in this particular through this particular resistance. Okay, so ISC will be 75 I. Okay, now we have to find I equal to V in. Okay, minus, see the value that is given here, minus V0 by 10 power 4. But since we have shorted, we have a short here, which means V0 will be equal to 0. So this voltage will be equal to a short circuit. So for writing this expression, it is sufficient that we write I equal to V in by 1 kilo. So which means substituting this in ISC, we get minus 75 by 1 kilo into V. Okay, now we have to find the Thevenin's resistance, which is equal to Thevenin's voltage divided by the short circuit current. This V0 we have already determined here. So substituting that, minus 2903 V divided by minus 75 V into 1. So this value will be 38.71 kilovolts. So this is the Thevenin's voltage and this is the Thevenin's resistance.